G'day guys. This is a video on Shawn Baker's high blood sugar levels, A1C, and low testosterone. And my take on that issue, which a number of vagoons like Mick the Vegan, that Bart K recently did a video on, and many others in that sort of community, and a number of other people in part of the low carb community or that sort of space, discussing this issue and wondering what's causing it, reasons. It's usually people that are quite physically active that are noticing these things. But when they look at body composition, the results, the muscularity and stuff like that, it sort of goes against the sort of the logic that if you're doing a lot of physical activity, you should be seeing an increase in growth hormone, testosterone, all these sort of things. And that's true, but there are, factors that can affect testosterone, and there are factors that can also affect blood sugar that a number of these people are not aware of, or, seem to have fallen into sort of what is called reductionist thinking. So they can't see the dynamic flows, ups and downs, so to speak, that happen with physiology under certain circumstances. And I recently did some videos with Jonathan, covering some of these issues about gluconeogenesis and the things that can drive it, and the person who Dr. Shivers, that was Robert, that was talking about, this insulin suppression and all that sort of stuff, and like sort of explained quite clearly, you don't see any of the biomarkers in the liver or in the kidneys or anywhere else that would actually show that there is a problem. But you do see an elevation of some of the pathways, the enzymes that are involved in gluconeogenesis. Obviously, if somebody's got very low body fat, that's what goes up there. And what happens as well? Testosterone is in the toilet because you've got less fat, and you're building less muscle as well, and you're actually using a lot of the actual food protein as a fuel. And that's why all those sort of effects are taking place. But in Shawn Baker case, there are other circumstances. Obviously, his level of intensity has something to do with it, but at the same time, he does consume a certain level of fat. So that he's not like super lean either. So that's not the issue like with the client that Robert had. So let's take a look at some information that I'll just put on. I'll share now. Give me a sec. Okay, so this is out of a study that was published in Nature that looks at the VO2, a number of athletes that were involved in pretty much I'll just trained cyclists exercised at increasing intensities, and the relative contribution of fuel for contracting skeletal muscles were measured with indirect calorimetry and tracer method. An increasing contribution of carbohydrate fuel, notably muscle glycogen, is observed at higher exercise intensity, free fatty acid, and calories adapted with permission from references from the American Physiology Society. So we're looking at here, and as we can see, the sort of different requirements. So somebody who's casually on a bicycle, just cycling around at a steady state, sort of, and not in high intensity, will basically pretty much the level of glucose that's going to be pushed into the blood glucose is going to be relatively much lower. As you can see, the plasma free fatty acids are going to be quite substantially more, because you're not uptake, it's the body's making it available, but it's not being uptaken as fast, and also the muscle triglycerides are going to be much lower. So once you actually increase the actual intensity to 65, the VO2 max of 65, so that's, an intermediate level of intensity, you can actually see that the blood sugar just bumped up quite a bit in comparison to just cycling around. Free fatty acids are being uptaken, and you can see the muscle triglycerides have gone up. So the free fatty acids, that means what's circulating in the plasma, in the blood, has gone down. And glycogen, muscle glycogen, has gone up as well. So you see that amount there, it's nearly double what at the very low, at the lower intensity. But to get to that sort of level of, muscular glycogen, to be repleting, you're going to have quite a bit of glycogen being pushed through the bloodstream, So you've got quite a bit of glucose that's going through to provide energy for those muscles. And when you're actually getting into the really active levels, look at this, it's, even more than double the previous amount at the high intensity of, VO2 max of 85. So this is very high intensity. This is the sort of stuff that Shawn Baker does. Look at his muscle glycogen, what the sort of muscle glycogen he would have off the show. And these are, let's be very careful, this is cyclists, okay? So this is in a different tissue type. We're actually going to look at the tissue types as well, which is really important, the differences, okay? So there's that tissue type, and will be the legs primarily, as you can see. So so just keep that in mind about, the upper body. Do you think it requires may require much higher amounts? I'd say so in that regard, but we'll look at it shortly. But remember, we were midday persistent hunters, and there are a few still in Africa that are, and obviously this sort of tissue is really designed, if you go into that high intensity, to really maximize the transport of glucose through the bloodstream. It's understandable. You need to transport more glucose in order to provide glycogen, repletion. Because at the end of the day, remember what Albert describes, you got your mitochondria, producing, they can use both glucose and free and fats as well. So through beta oxidation. So you've got both that can actually provide that. And then there's that phosphocreatine, where, the phosphate that comes off, and that release of energy of ATP, and that will actually power, to a large extent, the phosphocreatine cycle, because they're all interlinked in that regard. We need to get our heads out of this reductionist. This study is a bit annoying because it actually sees anaerobic and aerobic. They see it in this broken reductionist way, as if the body works like that. No, everything is interlocked and interplaying and intercommunicating and all that sort of stuff. So, you break any of those components and it falls apart. It doesn't work. So it's an illogical way of seeing, and pretty much you're passing on that phosphate, because you do need to basically produce from the glycogen stores, the muscle glycogen. You need at the filaments to produce ATP, because you pick up from the phosphocreatine, you'll pick up that phosphate, you'll add it to the ADP, creating ATP to generate the glucose for the filaments to be able to do those contractile effects that's the so-called anaerobic construct, you know. But that's what's happening at the filaments. Just contractile, you know, and then that will actually release that phosphate, which will be recycled to the phosphocreatine back to the other part. It's sort of all interlinked in the way it actually works, and one feeds off and supports the other, these three cogs, as Bart's explained it in other videos. I'm not going to get into details. I'm just giving a general sort of an explanation of how it is. So we can see here that obviously a person with the intensity of Shawn Baker's is going to be transporting far more glucose than the average person. So if he's trained in the morning and he's really bumped up his glucose transport to those muscles, and they're also being repleted with glycogen, and then goes and does a test, obviously they're going to find higher levels of, you know, blood glucose circulating. For Shawn Baker to basically show something different, and I've done this experiment myself, anybody can do it. You can do it at home as well. Do 2 days really intense, and then check your blood sugar in the morning with actual needle. Then you need 2 days washout. So couch potato for 2 days. Then in a fasted way, then check your blood glucose levels. They'll be back down to that much lower level because the body will go, oh, doesn't seem to be very active. He doesn't really need much. We don't need to traffic a lot of energy to his muscle, to the person's muscles. And you'll see that the body is very dynamic. It'll actually look and say, you know, if in the evening you're sort of less intense because you're relaxing, you know, you're taking it easy, the body will go, oh, okay, this guy's in a relaxed mood, or this woman. They don't need as much. We don't need to be pushing, and it will start easing down to this lower base level, to a basal level through the night and all that. That's what's actually happening. So you've got somebody who's extremely intense in their activity, and obviously they're pushing the level of circulating glucose. That means they're upping their gluconeogenesis. And I suspect if Shawn actually did tests to see his, you know, going and doing a blood, you know, a sort of a test to see the amount of circulating at different intensities, he would notice those differences. You know? So anybody can do it. You can do 2 days, then a washout, then 2 days, then another washout, because you need to do 2 days in between for a washout, you know, because even when you get into ketosis, your blood sugar will rise on the first 24 hours. And then as ketones start coming in and more free fatty acids get released, then the glucose starts dropping off, unless you're doing really intensive stuff like Shawn is doing. And he's definitely doing. He's really pushing. You know, he's extremely physically active in order to get to that world championship level, because that's his competition level, and that's what's happening. So, you know, it's absolutely nonsense to be talking about. And as Bart pointed out, you know, that level is where he is because he's training at that intensity and that level that he needs that extra muscle glycogen. So his body will transport the amount that he needs. And it's simple as that. And obviously the low carb, because we're less inflamed, we damage less our red blood cells. We turn them over much over a longer period of time. And so for us, you know, A1C is less of a good marker. I've had A1Cs all over the place. So, and I can't really put it down to anything specifically why that would be the case. You know, maybe, you know, I had some illness at the time or a virus that I wasn't aware of, and it sort of, you know, sort of had a bit more turnover, maybe not, don't know. It's a complicated thing. Usually in people that are diabetic, they just don't have a high A1C. It's not like something like in the 5s or 6s. It's usually like 7, 8, 9. It's really high. That's what these people tend to have. Even the pre-diabetics can have really high levels. We don't see that with Shawn. It's slightly elevated, but that's due to the amount of physical activity that he's doing, and he's producing far more glucose. And so he will be glycating slightly more his red blood cells because he's transporting because of his physical activity. And it's not only him, but a lot of other athletes are noticing something very similar. And it's even athletes that are not even on a carnivore diet, on other diets. So it's not specific to carnivores. It's not specific to keto people or low-carb people. It's noticed across the board that this is the case. And it's really fundamentally down to pretty much transporting more glucose through the bloodstream to replete muscle glycogen. That's really what it is. And that's what all the physiology sort of textbooks show. Higher intensity, you'll be pushing. So sprinters, weightlifters, or rowers like he's really intense, pushing it to the max. That sort of anything that has to do with that will see higher muscle glycogen levels, and also we'll see higher amounts of circulating in the plasma, in the bloodstream, circulating plasma glucose. So this is physiology 101. This is basic stuff, and that's why even Bart laughed with Mick the Vegan, because it's just ridiculous. This is basic, well-known stuff. Most sports physiologists know this quite well, that this is what happens, the amount of circulating. So do you think they don't take blood tests and check for ketones and check for blood sugar levels and all this sort of stuff and a whole lot of other parameters? Or do you think they get paid to do nothing? It's just sports physiologists, pretty much a lot of them are aware of this. But Mick the Vegan and many others like him, and many of these other sort of what I call influencers, or within different communities that aren't aware of this information because it's not their occupation. They're not, and they haven't looked into it. People like me have. People like Bart have actually are far more knowledgeable than I am, or many others on the interwebs, for the simple reason that he's a sports physiologist he's got 4 advanced qualifications, and that's one of them. The others are in cardiophysiology. The other one is in nutrition, and I forget what the 4th one is. But anyway, so we're talking about a person that understands this sort of stuff, and I can understand why his eyes roll with the sheer nonsense that Mick the Vegan actually spouts out of his mouth. Now, let's look at this study. So this is looking at multiple studies have shown that resistance exercise can cause acute changes in serum testosterone concentrations. That's quite clear. Circulating testosterone has been shown to increase immediately after a bout of heavy resistance exercise and return to baseline. This is, and the or. The or is a very important one. Or even decrease beyond the level within 30 minutes post-exercise. So that means it can fall to much lower levels post the exercise if it's been, we're talking about resistance exercise, and the intensity is really important, and the tissue type is really important. So we're going to go to that, and we'll look at that shortly. So keep this in mind. This is important. So 30 minutes after, and I would suspect he probably I know that Shawn Baker exercised early in the morning, and then after that he would go and actually do a test. So what do you think's happening? By the time he drives there, probably by the time he actually has all that, it's past 30 minutes, he's probably dropped to that lower part. Oops. He's getting the result that, where, and that's the thing with testosterone, it does vary throughout the day. So, as it says here, a major determinant for the increase in plasma testosterone concentration is the muscle mass used. That's true. And the type and all that involved by involved of a small muscle mass, even when vigorous resistance is performed, does not elevate serum testosterone concentrations above resting levels. So when you've got small muscle mass, even when you're very vigorous, like Mick the Vegan, you're not going to basically raise it above the serum levels. It's going to be basically a sort of a flat line. So it won't go down, it won't go up, it'll sort of remain sort of more flat. So that's also what research shows. When you've got higher muscle, obviously then the intensity is playing a role, and which tissue type. Now let's look at the tissue types that exist. So trapezoid muscles, these are all this upper body stuff, all this top, the shoulders, all these back muscles and stuff like that, and all these, the neck muscles as well. So you've got the neck muscles, all these sort of the upper back, the neck and all that. Those muscles are the ones that you use for rowing. And also a lot of that heavy lifting and moving large things and throwing them up as he throws those big balls and all that. You're using all these shoulder, these neck muscles, all that is sort of tensing and all that. You're really working all that part, that that top of the upper body. You're not, the core, you're not actually working as much. It's really that upper part. But that's what he's focused on. Shawn wants that to be the strongest. Why? Because he's a rower. And if that's not the strongest part, you're not going to be very competitive in rowing. Okay? So that's the part that he's actually using, which is really important. Now let's compare that with the leg muscles. Okay? Now I've got a study on this drive page. The expression of androgen receptors in human neck and limb muscles, effects of training and self-administration of androgenic anabolic steroids. But we're not going to worry about that part. We're just going to focus on the tissue that has the more receptor sites. So you're actually talking about myonuclei, which I've talked about before. Okay, so certain tissues have more of that, and it's sort of, that's where your muscle memory. And guess where the majority of that is? In your legs. And why wouldn't it be? We're midday persistent hunters. We need to have that muscle memory. Very important. But it's less in this upper part. But guess what's more in the upper part? The androgen receptors. So what do those androgen receptors need to work? Oh, testosterone. You getting the picture? So when we look, is this going to work? Okay, so as you can see, the AR, which is basically the androgen receptors, as you can see, there are far more in the upper body part. Got it? Compared to, so for power lifters, but compared to basically the legs. Got it? And when it comes to the myonuclei, the legs have it by just a bit, not much, not a massive amount, but slightly more. But the receptors So this is the difference. So somebody doing a lot of, this is why I believe that a person who's doing far more that upper body part intensity, there's a lot of androgen receptors. So they're going to take up more testosterone for that anabolic effect. That's where his testosterone is going, and it's lowering post-exercise, that 30 minutes after. And it probably takes a couple of hours then to come back up to baseline. But he's already had his test. And his test is showing that he's got a low T, but he's using it. Because he's got receptor sites to be able to use it. And I think that's what's actually happening because of the style of exercise that he's doing. And there's a lot of other people that are doing high intensity and are noticing similar effects. So it's not only Shawn, it's many others. And the literature shows that. Shows that this happens after a lot of intensity. And the reason it happens is because, guess what? There's more receptor sites in that tissue, androgen receptors. So what is going to happen if you basically activate and start working that sort of tissue, it's going to call on more of those, more of the, the testosterone for those receptor sites. That's what's happening. It's no different than basically when you're sick and your vitamin D levels change as a consequence of those receptor sites taking up more. The active amount, circulating changes and all this sort of stuff. These are the dynamics of the body. The body will pull on what it needs, whether it's a cofactor or whatever it is, to do certain work. It's a dynamic system. And so if you're physically working certain activity, it will call on those elements and you'll see a dip. As they're noticing in research, they're noticing that dip in testosterone from that excessively, and in particular, when you're doing this upper body part, which is what a lot of weightlifters do, and a lot of, especially people like rowers and stuff like that, and they notice this drop. But they're very strong, very physical. It's just a consequence of their activity and what they're doing. So we need to realize that this is happening to a specific group of people doing specific activities who have got more androgen receptors in the tissue that they're actually working. And they're going to call on more of that T into those receptor sites. That's what's happening. And that is why the levels go down, as that research has pointed out. So without complicating things and going, people can read it if they want to. That's why I'll put links, as I always do. But this is my sort of take on it. And this is what the literature shows, that it's just a response and all that. So in order and I don't think Shawn's going to basically stop his intensity because he loves it. That's his training and that sort of stuff. For him to basically stop and be a couch potato for 2 days in order to take a test and all that, he couldn't be bothered. And I don't blame him, because it does not affect his performance. Because if it did, he'd notice it and he wouldn't be winning world records. He's winning world records because he's utilizing his T like somebody, unlike others that are not. Just because you've got more free stuff circulating doesn't mean it's actually healthy if it's not being used. Well, if you're the goon, there's not much anabolism that's happening there. So, so yeah, you may have a certain level that's continually circulating day and night. Nowhere to go, because the goons do not have sufficient muscle density to utilize it, especially in the upper part of the body. So yeah, it's pretty much nonsense once you get your head around the physiology, the sort of energy requirements of that physiology in certain training scenarios. It all sort of makes sense in that regard. But unfortunately, a lot of people out there have this reductionist way of viewing things, and they can't see the dynamic interplay of all these tissues and the activity and all that. And so they get fixated on numbers. It's reductionist thinking, it's sort of being sort of with blinkers on and just not being able to focus outside just that pathway, that single pathway, that single number, as if the body is like a fixed to this level. It will not shift at all. That's nonsense. The body's dynamic all day long. Our cortisol goes through circadian rhythms. Everything goes through these different circadian rhythms, and depending on the way we operate in the world, the way we interact with the world, a whole lot of things change. And the body also anticipates going, this person's a bit more active. Let me just up a bit gluconeogenesis. Oh, this person's just, he's been pretty much a couch potato a bit. Let me down. Now, if you were to go from absolutely being a couch potato and forcefully trying to do something really hard immediately, you will actually notice sometimes you may get a bit of dizziness. Guess what that is? A sort of the effect of hypoglycemia. You're trying to do a muscular thing out of just being couch potato for quite some time so quickly that the body just can't keep up to furnish that that glycogen immediately. And so, yeah, you may notice, I've noticed it in the past on very rare occasions, but it does happen. And it happens for those sort of reasons. You're doing something way too fast for even the body to anticipate. And the body doesn't know when you're going to stop doing something. So it'll actually keep the level slightly higher, and then will slowly drop off as the activity level. There's been a period of time that has actually lapsed, that the person's been, sitting around watching TV or whatever, and then it will sort of drop off. It won't drop off immediately like that just because you stop lifting weights. So, and that's why he may be running a much higher level, because there's the expectation by the body that glycogen needs to be available, for those muscles to work, because they're going to be put to work potentially. And that's how the body works. It anticipates certain things, and it will basically temper down insulin signaling, because it knows it doesn't want to inhibit gluconeogenesis. So the body's really smart the way it does that. Where if you're a couch potato, it's not an issue. So if you have something immediately, if you're insulin sensitive, it'll drive down with a lot of insulin that. But if you're physically active, it won't, because you've already in the muscle, the signaling, the insulin, the IGF-1, the mTOR signaling, all this is pushing and telling the body you're working this sort of tissue, provide it with energy, is what it's saying, because the body's smart. It's not stupid like Mick the vegan. It understands that it's a dynamic system that will make sure that there are a certain level of circulating, energy in the form of glucose or fatty acids to basically provide those tissues the ability to produce their glucose for the filaments and also the energy from pyruvate and from beta oxidation to the mitochondria to produce the ATP. Body's smart, knows what it's doing. There's just a lot of dumb reductionists out there, people that can't get their head around this dynamic interplay and sort of make up problems that don't really exist. It's only in their head because of a lack of understanding of physiology. Anyway, I hope you enjoyed that little rant from yours truly. Anyway, see yous.